Welcome back. This is lesson 17.3, and in this lesson we're going to look very briefly at a kind of software called an operating system. This presentation is just an overview. My students have an information booklet which will fill in some of the details. I'm just going to briefly review some of the issues that arise. You need to know the purposes and functions of an operating system. You need to be able to describe some of the tasks an operating system performs. And this won't come up in the exam, but I'd like you to also think about what actual names of operating systems you're familiar with, because that will help you to understand what an operating system is. The purpose of an operating system is to manage the operation of the computer. The operating system provides the user interface that lets you, the user, interact with the hardware and software. It allows software to run on the processor. It loads it and engages it with the fetch execute cycle. And it connects and coordinates the peripherals, the various hardware components that make up the complete computer system. So these are all really important tasks. So some of the functions that the operating system will have to be able to perform in order to meet these requirements, they must schedule the processor time. So a processor can only do one task at a time. So if there are lots of tasks to do, it'll be the job of the operating system to give each task some of the processor time. It will also interrupt tasks that the processor is undertaking to schedule new tasks. It will manage the RAM, the memory, the active electronic memory of the computer, and the storage that is linked to the computer. It will manage all the peripherals like the mouse or say the microphone that I'm speaking through now, and many operating systems handle system security as well. So you will need to know about several different types of operating system. There's much more details in the booklet, but let me just quickly go through them now. Multitasking system, this will be the type of operating system that you're familiar with. You can carry out several different tasks on the same computer at the same time. Of course, the processor is really only doing one task at a time, but the operating system will swap between them so quickly that you won't really notice. So you could be playing music while you're doing your homework using a word processor, for example. Larger computers can have multiple users working with the same processor, so a large mainframe computer might be like that, and in that case the processor itself is swapping between the tasks set by the different users, and if the system is powerful enough, each user will experience what is effectively an uninterrupted interaction with the processor, so they won't even notice that it's slowed down. Distributed systems are more or less the opposite. This means that one process is distributed over multiple computers. We often do this when we need to combine the processing power of many different computers to do one very difficult task. Real-time operating systems are operating systems where the timing of events is absolutely crucial. For example, we're operating with something that, as it happens, needs to be controlled by a computer. For instance, a warning sign or an aircraft autopilot needs to respond lightning fast and deal with real-world events. And embedded operating systems, these control processors that are embedded in other devices. For instance, you might have a processor in your car or in your central heating, your fridge or whatever. So those are embedded operating systems. So that was a real quick tour of the 5 types of operating system. As you will have heard, in many of those types of operating systems, the processor has to swap between different tasks. And the way it does this is that an interrupt signal will interrupt the fetch execute cycle, the instruction cycle. And so an interrupt stops the current instruction cycle and makes the processor swap to a new task. Used in two different ways. One is if something happens as an emergency, and so an unforeseen thing happens and everything else has to stop on the computer, for instance, some kind of big hardware problem. Or secondly, and much more frequently, it's used to allow the computer to undertake multiple tasks, and the interrupts happen at regular intervals, probably several times a second, as the processor swaps between different routines. And ISR, that stands for Interrupt Service Routine, and that is the software within the operating system that implements and handles interrupts and make sure that the processor swaps seamlessly between the different tasks that it needs to do. I mentioned memory management. The operating system helps the processor to interact with RAM to fetch the instructions and data that it needs. That means it has to keep track of where all the different software and data files are in RAM while they're open in the electronic memory. There are two main ways that it does this, called paging and segmentation. Both of these mean splitting. The memory is split into sections, and the operating system sets aside different sections of memory for the different programs that are open at the same time. And this is almost universally done. The main difference between the two methods is that paging uses pages of a fixed size. Think of how the pages of a book are of a fixed size. They don't grow or shrink, whereas the segments in a segmentation system can be bigger or littler depending on the how much memory is needed by the different software. So segmentation is a bit more flexible, probably makes better use of the available memory. It's a little bit more processing requirement for the computer. However, sometimes all the pages or segments are used up and there isn't enough space to open all the different software that you want to have open at the same time. And in this case, some of the data and software which ought to be in electronic memory for most efficient use of the computer gets copied into virtual memory. Virtual memory is not real memory. It's the use of storage, for instance, the hard disk of your computer, to stand in for memory if you haven't got enough RAM going in your computer for all the work you want to do at the same time, and that will really slow your computer down. So remember, the word virtual means it's not real. So it's not real memory, it's storage instead. It's the hard disk of your computer. You can avoid this problem by installing more RAM into your computer. So just to remind you, memory is divided into blocks. The blocks are allocated to software. In paging, the blocks are of fixed size. In segmentation, the size is flexible. And in virtual memory, some of the blocks are put in secondary storage. Another job of the operating system is to manage the hardware that makes up the computer system. The BIOS is the basic input-output system. It's one of the first bits of software that is loaded into RAM at startup when you switch the computer on, and it just enables the computer to communicate with input and output devices. Otherwise, you wouldn't be able to work with the computer at all. And then there are other more specialized packets of software which we call them device drivers, and that's all the instructions that enables the computer to work with particular items, particular keyboards, for example. In modern operating systems, Most of the device drivers that you need are already in the system. They're part of the standard download, and that means you can more or less buy a new keyboard, buy a new mouse or whatever, and just plug it in, and that's called plug and play. Occasionally, if you buy a rarer or newer kind of hardware, some specialist gaming input device, for example, you might have to download a device driver off the internet. When you buy the hardware, it should be made clear to you what you have to do. I've said that one of the jobs of an operating system is to schedule the use of the processor, because the processor can only do one thing at a time, but there are often multiple tasks going on inside the computer. Again, I'm going to go through this real quick. There's more detail in the handbook. The 5 methods: first come, first served, shortest job first, round robin, shortest remaining time, and multi-level feedback queue. That final one is the way that modern scheduling software would probably work, but let's very briefly look at those 5 methods of scheduling. So remember, the job of scheduling is to allocate processor time to the different jobs that need to be done. The first 4 methods fall into 4 broad categories. You can either put the jobs into a queue, so the computer clears one job, then moves on to the next one, or you can use multitasking. If the computer is getting on with its work without a person around, then you might use a queue, for instance a print queue. But if a person is working with that computer, you'd probably use multitasking, because then the computer will be apparently working on all the different tasks at once, and that's much more how we want to work. So some of the scheduling methods use a queue and some use multitasking. Within those 2 broad categories, we can make some of the tasks more important than others, so they're cleared quicker, or we can give all the tasks an equal chance to get done. So in a queue, if all tasks have equal importance, it'll be a normal queue. The first items into the queue will be the first that get cleared, and print queues usually work like that, and that's called first come, first served. Another way of doing queues, and sometimes when computers are very busy this method is used, is to clear all the little jobs first. And that way the queue starts to go down very rapidly, and the long jobs that take a long time get left to the end. You can imagine the advantages and disadvantages of those methods. So a very long job might end up waiting a very long time in the queue. Moving on to the multitasking scheduling methods, a round robin system will just swap between all the tasks, giving them all equal time on the processor. So it will just go round and round, probably every second or fraction of a second, it will give some processor time to each one of the tasks that are in the queue. However, occasionally in a multitask system, we use a kind of privilege the tasks that are nearly finished. So it's similar to the shortest job first, and those tasks are given a bigger share of the processor time so that we can get them out of the way nice and quickly. The price that we pay is that some of the other tasks might slow down and take quite a long time to clear. So those are the 4 methods. But the winner is the more modern method, which is called a multi-level feedback queue, and that really is where the computer does a much more complicated job. It creates multiple queues, so it uses the queue method, but then it swaps very quickly between the items in the different queues using the multitask method, and it takes into account all sorts of priorities and feedback from the jobs, so that it's always giving you the best possible scheduling for whatever work is underway. And that's clearly the winner over the other 4 methods, but the other 4 methods are still used, for example, in print queues, so you need to be aware of them. Okay, so I've very briefly gone through some of the issues around operating systems. There's more detail in the workbook that I've provided to my students. See if you can create a presentation. So I'll put you in groups. Again, if you're my student, I'm going to put you into a group with some other students, and you've got to create a presentation about operating systems, covering all the points that are in the booklet. Don't worry, you don't have to give the presentation, but if you agree, I might share it on our Moodle. Okay, and if you're not my student, well, you can still do this activity, of course. Okay, so that's a very quick overview of operating systems. We'll continue with the software theme next lesson. Bye for now.